Hey guys and girls, this is section 6.4, rational exponents or exponentiation for rational exponents. And what we're going to talk about here is situations where you don't just have a nice integer power. We've dealt with x squared and x to the 34th and x squared over y cubed all to the 6th and things like that, but you'll notice in all these cases the exponent is an integer. You haven't had any negatives, any fractions, and so on this section we're going to expand what we talk about to rationals. So that'll include any rational number, which if you remember is a number that is or can be written as a fraction of integer over integer. So there's a few rules we need to get out first, and then a couple examples. This is all from section 6.4. Okay, and the first rule is a negative exponent. Such as the formula version, x to the negative n. And this is one of those cases where it doesn't really make sense to apply exponentiation because you can't multiply a number by itself a negative amount of times. But what that negative does is it moves the power to the bottom. So x to the negative n is the same as 1 over x to the positive n. So for example, you just, x to the negative 2 is the same as 1 over x squared. And that can be proven using our subtraction rules that we had on the last video. Like, x to the 3 over x to the 5. All right, because our rules of subtraction tell us that this is x to the 3 minus 5, which is x to the negative 2. And at the same time, if you take this and write your 3x's on top and your 5x's on the bottom, and cancel some of them, then you get 2x's left on the bottom. So you can see that these two things are equal in that way, even if multiplying x by itself negative 2 times doesn't really make sense. It's still our correct version of the formula. Okay, so rule 2. What do we do with 0 as an exponent? You can't multiply x by itself 0 times, but I think I showed this one. We're using the subtraction rule. Anything to the 0 power is always 1. Unless there's one case that's not true. If you have 0 to the 0 power, that's undefined. That's not equal to 1. But anything else raised to the 0 power equals 1. Okay? The third rule is for reciprocal exponents. And that rule is x to the 1 over n is the same as the nth root of x. Okay, so there's a very strong connection between roots and exponents, and this is that connection. For example, if you have the square root of 9, and it's an unspoken 2 that sits right here on the root symbol, it's kind of like when we write x, we mean 1x. You don't have to write the 1 every time. So the square root of 9, we know this symbol is only positive square root, so that's 3. You could also write that as 9 to the 1/2 power. Excuse me, 9 to the 1/2 power equals 3. So a square root and a 1/2 power are the same. So a cube root of 8, for instance, the cube root of 8 is, what do you need to multiply together? 3 times to get 8, that's 2. We could also write 8 to the 1/3 equals 2. So an nth root and an 1 over n power mean the exact same thing. Okay, and our final one kind of expands on that rule, and that's x to the a over b. So if you had an exponent like 3/4 or some rational exponent like that, we've got two parts basically. This is like x to the a times x to the, no, I take that back. This is like x to the a to the 1 over b. Because a power of a power, you multiply the two exponents and you get a over b. And then if you take that 1 over b and consider it to be a bth root, you get the bth root of x to the a. So that just kind of is what you do if you have a fraction, and this one applies if there's something other than 1 on top. So for example, 4 to the 2/3 power. That's the same as the cube root of 4 squared, which is the cube root of 16. I'm not sure what the cube root of 16 is. Let me make up one that's able to be simplified. How about 8 to the 2/3 power? So this is the cube root of 8 squared. And you can apply the cube root or the squared first. The cube root of 8 is 2, so this is 2 squared, which equals 4. Or you could do it like the cube root of 8 squared, which is 64. And since 4 times 4 times 4 is 64, that way works as well. So there are 4 rules, and let's do a couple of examples. Start with one like this. 11p to the 7th times 4p to the negative 12th. Okay, so first of all, coefficients 11 and 4, they don't really have anything to do with these exponents because the 7 only applies to the p and the negative 12 only applies to the p because there were no parentheses. So the 11 and the 4 are kind of on their own, so I'm just going to get them out of the way and make that a 44. And then I have p to the 7th and p to the negative 12th, and a negative exponent moves it to the bottom. It makes it positive. So now I can subtract. The 44 is still just hanging around, and I basically cancel 7 p's from the top and 7 p's from the bottom. And I'm left with 5 p's on the bottom. Now it depends on the direction, and this set of problems in your book, it says don't leave any variables in the denominator in your answer. So if that's the case, I would want to write 44p to the negative 5. Those are the exact same thing, and you just have to figure out which one the question asks for. Maybe I'll give you a question that says don't give any negative exponents. And this version has a negative exponent, and then you would move it back to the bottom. So those are interchangeable. It just depends on which one the directions are asking for. Okay, and one more good one. Let's do r to the negative 5th times s times t to the negative 3rd over r to the negative 1 times s to the negative 5 times t. And usually we interpret it as negative exponents move to the bottom and become positive. But these exponents right here are negative and they're already on the bottom. So basically what you need to know is if you cross over the fraction bar going up or down, you change the sign of your exponent. So I'm going to take my 5 r's that I had to start on top that were negative and move them down, make them positive. And take my 1 r up top and make it positive. I've got an s on top, and I've got 5 negative ones on the bottom that I'm going to move to the top and make positive. I have a t on the bottom, and I'm going to move the 3 negative ones down. So the negatives, I just got rid of all of those by moving them from bottom to top or top to bottom and flipping the sign no matter what. Okay, so now I can simplify. Looks like I'm going to have 6 s's on top. I had 1 r on top, but I have 5 on the bottom. So I cancel 1 top and bottom, and I'm left with 4 on the bottom. And I've got 4 t's as well on the bottom. Okay, so again, because the instructions say don't have any variables in the denominator, this is a correct answer, but it's not in the form that the book looked for. I need to write it like r to the negative fourth, s to the sixth, t to the negative fourth. And that will both be correct and it will fit the form they were looking for. All right, but realize these last two things are identical. It's just 6 of one, half a dozen of the other, depending on the instructions. Okay, so we will cut it off there. We will work on this in class tomorrow, and make sure that you finished up your 6263 at home if you did not finish that in class. All right, I will see you then. Have a good night. Young out.